So it's a roasting hot day today in the UK, and here you can see the fake car operating on the bench with the MCM here. There's no BCM now, and the ECM under there, and here we have the Orion 2 BMS. It's not connected to any batteries, but it's just spitting out CAN data. This is also spitting out RS485 data on the MET SCI and BAT SCI lines through these wires here. We've got a current sensor. And so basically one of the members was asking about a cut down version of the schematic just for use with the Orion BMS. So I did knock up a schematic, and I've actually built a board today, and you can see it there. I'll try and explain things. It's running some pretty basic code which I have been using successfully in the past. So we've got a number of connections. I'll try and hold the phone still and just explain what's what. Now this one I've actually added two extra features. I've made this a multi-purpose board, so this has also got the high voltage detection circuit, the isolated high voltage detection circuitry, so the high voltage detection could go in here if you don't have an Orion BMS. This also has the Allegro current sensor input here if you don't have the Orion BMS, so this could be used with an Orion BMS or without an Orion BMS. And then we have the CAN data going in here into the little CAN data daughter board, which you've seen I've mentioned before. And we've got the 2680 PIC and just 3 LEDs for diagnosing what's going on. 12 volt power in here, switched ignition power, and then we have the MET SCI data in from the BCM in this connector here, and the BAT SCI data back out to the MCM here. So this is basically just sitting here chugging away, doing what we were expecting it to do. Obviously it needs testing in a car now. I should be able to do that because I've got the HV detection and the current sensor potentially operating now. So a little bit more bench testing, and it should operate as the Bcm Replacer. That's the theory. Obviously this is just a rat's nest on a piece of strip board, and this all could obviously be massively simplified and squashed down with some surface mount chips if necessary. It'd be fairly easy to squash that down, probably to a quarter of that size, with some basic chips, or even some even using through-hole components with an actual proper printed circuit board, 2-layer board. We should be able to squash that down to probably at least a quarter of that size, which would make it quite a nice little replacement. So that's where we are at the minute, and I'll do some more testing on it later.